So here we go. I think we've managed the technology. First of all, you can see the title we're going to talk about, and I'm going to share the presentation with my wife. First of all, we ran a business for 18 years together. And I don't know if any of you have ever worked with your wife professionally. You might well see the result in this talk. So, just a little bit about ourselves. I'm going to introduce myself. So before we went to Kenya in 2000, I'd never worked in the private sector. I'd always been a lecturer or worked in NRI. So it was quite a shock to leave the confines of the public sector and go into the private sector.
Jerry took that, didn't he?
He did. Yeah. So Jerry Cooper took this photograph in about 2003, and this is our farm we bought, which was coffee then, and there's not a coffee bush left, and it's not far away from where Frank was based for a little while as well. Okay. So.
Can you take that, Graham? Can you take the budget that's reflected on the screen? Graham's budget, I think it is.
Oh, no, that's not £1,000.
Is it not?
Right, it's like water.
I think it's the cursor. Is it? The cursor. No? There we are.
Okay, I think we're good. So Louise, introduce yourself.
So I'm Louise Labuschagne, also Louise Wainwright, and I was in the private sector, and I think that's how we got to Kenya. I went as a consultant to a private company, Finlay, what was it called? Homegrown, then part of Finlay's. And that's how we actually went there, was with the private sector. And it is a long story, but we did start eventually our own company there, Real IPM Kenya, which is what this story is all about.
And we are talking about Kenya, and just to remind you where Kenya is. But the question when we left England was, can you do biocontrol on the equator? Because Louise had been working in temperate UK, and some of the practices you were saying.
Yeah, I worked in predominantly soft fruit in the UK, and I did a lot of work with entomologists in ADAS who were also doing integrated pest management with real growers. And when we left to go to Kenya, I remember very distinctly being told, oh, you'll never make it work on the equator. Why not? Oh, well, because you don't have a winter to kill off all the pests. That's very interesting, because actually what we discovered when we were there is that the power of the equator is what gave us all year round opportunity to develop a sustainable strategy. So actually, I'm very proud to say that together, we with our group of Kenyan scientists, young scientists and young workers with Real IPM in Kenya, we did what a lot of other people in other parts of the world have still failed to achieve. And the power of the equator.
Well, that'll be our conclusion. Okay, let us move on. I wanted to bring up this slide because most of our business was in the horticultural sector. But I'd like to talk about, first of all, you have growers and you have subsistence, cash crop and export growers within Kenya. And then you have their farm size, which tend to be, the subsistence farmers tend to be very small, cash crop, difficult to make a generalization, small to large, and likewise the export growers tend to be large, small to large. And then the type of crops these people grow, your subsistence, you're down with these three crops with a bit of fruit and vegetable, But then if you go to the export growers, they were fine. They were all down there. Now, this has relevance when I'm going to pick some case studies to talk about. So we'll be referring to what our customer base is in this this story. So you'll all be familiar with the classical biocontrol of Africa and the story, and there's some stunning successes. Cassava mealybug, cassava green mite, and water hyacinths, and published data indicates that the savings were enormous for these classical biocontrol, and they were all state government donor funded and really had little input from the private sector. And the disappointing one, of course, is water hyacinths, that hasn't really been sustained and has come back after the money and the donors dried up. So Lake Victoria is still in a bit of a state. But really success stories of biocontrol in Africa. And then we have biocontrol in Kenya in year 2000 when we arrived. And so basically there was no production of any biocontrol agents that were available commercially. There was no registration mechanism. You couldn't get approval to sell them and use them. People had done trials with imported BCAs, but these were expensive and basically very limited or zero implementation. So that's the situation when we arrived in Kenya. And can I just talk a little bit about pesticides? We had extensive use of pesticides, particularly in the horticulture sector. Okay, and there was increasing pesticide resistance. Some pests were very difficult to control, e.g. spider mite. Generic pesticide availability was widespread, and generics equals low cost. Now, I relate that to the cost issue is because if you're introducing a new technology to replace a cheap technology, you're struggling to begin with if you're competing against a price. So we're going to describe 4 case studies to you, and then we're going to come up with conclusions. So we're going to talk about red spider mite in ornamentals. We're going to talk about striga in cereals, ticks in cattle, and fruit fly in mangoes. So we hope to cover a bit of the sector, and then maybe some conclusions at the end. I'm going to hand over to my wife, Louise. So that's forward and backward, and that's the pointer, if you need.
So, as Henry said, the drivers, I would like to say the drivers were the environment. Everybody cared about the environment, but actually you need to make a buck because you have to pay staff. The driver was pesticide resistance. And in an ornamental crop, you can't afford to have any damage at all. So actually, the fact that we achieved our main customer base in a crop on the equator with all year round growing conditions for a major pest, spider mite, which the massive international pesticide companies hadn't actually got the resources and the new products to sort this problem out. Hey, we did it. And my father used to say to me, South African, used to say to me, there's no such word as can't. And as a child, I used to think, actually there is, it's like can't. But what he actually meant was what I feel now, is that you can if you want to. And we really did want to. So, 50% of the crop production inputs into crop protection inputs into roses was actually for spider mite control. And the unintended consequence of that, of course, on the equator was keep spraying because it wasn't working, and therefore the resistance was accumulating. And because there weren't any other alternatives at that time, as Henry said, actually there were no locally available biological control agents. And if there happened to be any indigenous predatory mites that happened to wander into the crop, they were soon annihilated by the very good application technology and the frequency with which pesticides were applied. But, of course, although we've got there was a lot of customer pressure. You don't eat roses, do you? No. So why the customer pressure to reduce pesticide residues on something that actually you don't eat? Well, it's because of Greenpeace and Pesticide Action Network. They're testing the residues on the roses from Kenya on Valentine's Day and saying, would you give flowers full of this, chemicals to your lady? Answer, obviously no. So we work very closely with UK supermarkets in Kenya and in other countries. And yeah, we did it. But we had a lot of things that needed to be done, before then. First of all, actually, we needed the registration agency, Pest Control Products Board, to actually understand what biological was and to allow them to be used, and they needed to be registered, and they, so we had a lot of help from DFID at that time, who organised that this facilitated the biological control agents registration, and we did have speakers from all over the world coming to explain. And let me tell you something. The European Union has said, let's fast track biological control registration because actually we need to reduce chemical inputs, because what about the environment, How long ago was that legislation, that directive? At least 20 years. What's happened? Not enough. What happened here on the equator? Within 3 days, the stakeholders, led by putting an enabling environment, we'd got the framework for registration, which actually they didn't know what they were doing at the time, but that provided the enabling environment that has enabled biological control to really fast track. The Europeans know nothing about fast. The Kenyans did, and we were very lucky to be there and to benefit from that. We started our company, Real IPM Kenya, in 2003, having already started a previous biocontrol company called Duditech, fell out with them, and didn't go home to the UK. We sold everything we had, brought in every single penny we had, bought a small farm in Thika, and the rest is history. And yeah, it was very important not to import predatory mites from the UK. Why? Nothing to do with biology or adaptation or anything fancy like that. It was about price. So I would say that we, Henry and I, and Real IPM Kenya, were successful because we were released from the constraints of the retail price. So you could set up a fancy production unit for predatory mites, which we actually did, and also biopesticides, the fungi and whatever. But if you decided that you could make shed loads of money on this because you go and get the price list from Copper or one of the European agencies, wow, they're actually selling 1,000 of those predatory mites for £5. Blimey, we're producing millions of those in a day. And you get the calculator out and think, ooh, that's a good idea. But we did it, particularly in roses, in a totally different way. We went back to basics. and worked with the growers because they had a problem. They couldn't control this pest, and we worked out how many did you need to do the thing that Henry said, which is you can get 100% control of spider mite using predatory mites, but you can't if you just sprinkle a few here and there because they're very expensive. So, and then actually it doesn't work very well. So what do? Get the chemicals out and whack it over the head, and that's in some definitions is integrated pest management. But our definition was much more powerful. We would be putting in, Henry remind me, but we would be putting in something like 1 million phytocelas per hectare on one day. One day. You do your maths, that is a shed load of money. Which farmer is actually going to say, oh yeah, I got loads of money, have that? They didn't do that. So what Henry and I did was we figured out what the farmer needed, we figured out what the farmer could afford, and we made it affordable. As soon as it was affordable, it became doable, and that's what we did. And we did have a large home market. We knew how to speak to the rose farmers, plus they had a problem, and the supermarkets were saying, why don't you try this IPM thing? And the climate, quite apart from, it was completely the opposite of what people said when we migrated ourselves to Kenya, is it was the climate that made it possible because we had time. We have, I'm very proud to say, we now have 300 people, Kenyans, working for Real IPM Kenya, who have trailblazed. They're fantastic. I'm sure you all know spider mite, there he is. Got lots of different names. A pest that produces terrible cosmetic damage and very difficult to reach. So because they live underneath the leaf, and so pesticides quite difficult to get there. But these guys have got legs and they're hungry, so if they get under the leaf and sort them all out. And as I was saying, we needed to compete with what generic pesticides were, even though they weren't working.
What was that figure?
500, not 50.
Yeah.
Per month.
Per hectare.
Yes.
Yeah. Fantastic. Predator, Phytocelis persimilis. And, you know, the other thing is this, you need to get it pretty right because, you know that thing about the lady, usually a lady who gets the roses. Sorry about that. You also don't want roses full of itchy Phytocelis running all over them. So it was quite a thing to make sure you got the timing right, which is why you had to put the 1 million in, even when there weren't very many spider mite around. Because the other thing that researchers will be saying is you need to do the monitoring thing, figure out what the ratio is, put the right number in. But actually what you need to do is make sure that every single leaf has got one of these predators and able to walk from one leaf to another. So it's more the timing and looking at the pesticide residues. Were they even if it's a fungicide, were the residues compatible? Could you get establishment? So we basically had to provide a lot of technical support for our growers, and we never in the beginning sold, like the agrochemical company, we never sold pesticides just because that guy rang up and said, I want to buy some of your bugs. No, we didn't do that. It always came with technical support, because proper integrated pest management is not something you can read in a book. You know, it's about looking at the data, intuitive about the weather, about the spread of the pest and the predator. There was a lot that we had to look at. So you'll see here Phytocilus on the right hand side, beautiful glossy, spider mite on the left, and of course Phytocilus eats eggs, juveniles, adults. Very useful. And we did actually eventually, Henry, how many different Amblysia species do they produce now?
4 or 5.
We produced quite a number of other predatory mites, which were complementary, and Amblysius in general, produced in a different way altogether, but they don't need to eat so much. Phytocilus is really good because it's very hungry, and so they were a bit slower. They weren't good enough, so sometimes we would use a combination of those, but predominantly it was Phytocilus. So the thing is this. When you actually sort out a grower's problem, which it was absolutely massive, and suddenly you sort it out, and it was just this little bug that did it, something happens. The scales fall from the eyes, and they think, actually biological control works, because they really didn't think it was like snake oil or something like that. First question when you get back on the farm is, what are you going to do about thrips? What are you going to do about fungus, fungal diseases? Suddenly the door was open. We did start producing very early on biopesticides, which are naturally occurring fungi and bacteria. We worked very closely with ISIPE in Kenya. They had done a lot of bioprospecting and had isolates which they'd identified which were useful for various pests, but they hadn't commercialized them, and we partnered with them. And we also did our own bioprospecting, which Henry will tell you about. And we developed programs for roses, which included the use of biopesticides, biofungicides, and compatible pesticides. So obviously not all pesticides are compatible with the predatory mites, and we had to do that as well. So here you've got, actually that's an aphid with probably a Bavaria infection there, and here are some spores of Metarhizium. So yeah, we get complete control of red spider mite at the same sort of cost, and the customers were happy. And this is what happened. We weren't expecting this. You can imagine if you're being shoveled loads of medicine every day, pesticides, it's actually going to upset. I'm pretty sure you get the runs for one thing, but it doesn't help plants grow. As soon as we reduce the amount of chemical pesticides on our roses because of the reduction in acaricides, the stem length got bigger, the head size got bigger. Not because they were adding more fertilizer, because the plant was able to do what it wanted to do, which was to grow. And the price the farmer got for stem length and head size more than compensated for the fact that they were now using this risky biological control. So yeah, it really, that was the basis. Very surprising, because you would think that this wouldn't be the low-hanging fruit, high-value export crop, can't have any cosmetic damage at all. It did. And Henry's going to talk about, that's Henry there, look at him, he's so young.
So you, just a brief look at how we produce Phytocilus, and first of all, they're produced on bean plants in greenhouses or more likely rain shelters. And the order is you grow the bean plant. That's not as easy as you think, because you're doing it in the same ground 5 or 6 times a year. You produce the mites, and if you don't have the mites, you don't get the phytocilus. You infect the plants with mites, you introduce the phyto multiplies on the mites and consumes the mites, you harvest the phyto, you do QC, and then you dispatch the phytocilus to customer. Of all of those things, the biggest, most difficult thing was to produce the spider mite. It seems amazing, but that was the hardest thing to do, consistently, week in, week out. Anyway, and I showed at the time we were borrowing lots of money, and this is this bank manager who lent us the money at 17%. Okay. Anyway, that's a bit like that.
You paid it back.
Yes. We're now going to go to the other spectrum of striga control, and in cereals. And just to give you a glimpse, this is a field of sorghum, okay? But it's heavily infected with striga in flour. Let me tell you a little bit more about striga if you're not familiar with striga. So here is our maize plant. These are stems of striga in flower, and it's a root parasitic weed that's attached to this maize plant, probably at or very close to germination. Striga affects maize, millet, sorghum, rice, sugarcane. It's primarily a problem in equatorial Africa. In Kenya, this is when I was writing a donor project, I think it was for Andy, this is the type of justification we would get funding from. We would say that in Kenya there were 300,000 hectares infected, 21 million hectares of land infected in Africa, and annual losses in grain of enormous amounts. So that's the challenge, and we thought about biocontrol. Oh, and by the way, each plant, each one of these flowering stems produce 50 to 100,000 seeds. They are like orchid seeds, they're minute. Okay, so there we go. So biocontrol. So first of all, we're not the first people on the planet to try and control striga. And first of all, ISIPI were promoting desmodium. Desmodium actually releases substances within the root zone that will inhibit the germination of striga, very effective. Then we have herbicides, imazapyr, that could be grown with resistant varieties of maize, would control striga. There was a selection of varieties that were tolerant that you could consider. There were a very simple agronomic practice. If you grew a transplant and planted a bigger maize plant, it would grow away from the striga more easily. There were trap plants that would stimulate germination. And then finally, there's crop nutrition. Now, each one of these has a negative as well. Okay, for instance, desmodium grew so well that it was actually a weed. You were struggling, and if you didn't have an animal presence to control it, it actually gave you more work to manage desmodium. And also there was a seed shortage when we were operating this system. Likewise, the herbicide, the disadvantage is if you don't plant the resistant variety, you can't use the herbicide. So sorghum, rice, you couldn't use that herbicide. So there's always a catch. So we thought there was a place for striga. So we set up our objective, the objective to develop a commercial bioherbicide based on Foxy isolate initially in Kenya. Now, Foxy is the abbreviation of Fusarium oxysporum, which is a plant pathogen. Okay, and we initially got permission to use Foxy 2, which was an isolate that was taken from Ghana striga plants. and we worked with it for 18 months in Kenya, and it didn't work. And so we had to think again. The other benefit of using a biocontrol based on Foxy is that you can integrate it with all other crops, resistant varieties, herbicides, desmodium. You could use more than one approach to striker control. Now, the Ghanaian isolate didn't work, so we had to go out and look for our own isolate. And here is a striker plant, but can you see there's a black wilted striker plant there? And that is Fusarium oxysporum. The pathogen has got it. So we isolated that pathogen and applied it to the seed of the maize to see if it would infect and then control the attacking striker. If we just look, basically from left is control, right is the heaviest dose. So increasing dose left to right, increasing dose left to right. Nice growth response to the maize, and here full of striker and hardly any striker. So the technology, the bioherbicide worked. Okay, so we thought we've got a product. Registration was the next step, and more trials. And we had some serious questions to ask. The key questions were, was it safe for other crops? We had to convince the registrars that this Fusarium oxysporum only attacked striker and not lettuce, peas, and over 200 different plants Fusarium attacks. Who was going to buy the product? What was the potential market? Because I don't think our Fusarium would work in Ghana, because their Fusarium wouldn't work in Kenya. So a smaller market than we'd envisaged. And would it work even outside the field we isolated the Fusarium for? I'm going back to this picture. Who were the people here who would buy that product? And I'm going to suggest that that is virtually the only market we would be dealing with. What sort of a farmer grows that field of sorghum? I think it's a subsistence farmer. They don't put any manure or fertilizer in it. They use their own seed, which has a certain tolerance, but limited. This farmer has made no effort to control the weed. No use of existing control measures. So, are they really going to buy our biocontrol, whatever price we pitch it at? So no customer, no sales. We actually stopped the development work there because we had to make a little bit of money out of it. But now you might say, why didn't you ask that question right at the beginning? And all I can say is hindsight, you learn a lot during the whole process. Okay, so no more than that. At the same time, we were developing a seed treatment with just phosphate, and dramatic results. Treated, not treated, but we had similarly found that had an effect on striker. So we actually were promoting this fertilizer just as a cheap seed treatment that would also reduce striker. Anyway, that's another story. Okay, and then Louise is going to talk about ticks.
I know there's some people who are very interested in ticks here. So again, this was an isolate from Isipe, and as you know, ticks are a problem globally for similar reasons to the problem that we described in roses. There is widespread resistance to the few pesticides that are now used for tick control. And really because of the ability of ticks to also spread important diseases of cattle. So narrow selection of pesticides, same thing, very frequently applied, very familiar story. And again, there had been this isolate that has been discovered but not commercialized. And that's not an uncommon theme about the end point is the publication, not the application. And that's sad. And I'm very pleased to say that things changed a lot from when we first started in 2000 to where we are now. Commercial companies are not the bad guys that they used to be. They're not the ones that want to make all the money, so therefore don't talk to them too much, don't tell them too much, keep your intellectual property to yourself. And so that whole culture has changed, and I think that will empower more real integrated pest management. And in fact, I don't know if you're aware of this, because there are tick experts here, but there is actually a metarhizium, MET 52, which is actually registered in North America for the control of ticks. Really, I think that started because of Lyme's disease on humans, and not perhaps so much because of the effect on animals. So yes, it can be. MET 52 registered for use in North America. So this is the frustrating thing, you see, because in the registration efficacy trials, you can use your metarhizium either on the animal, because the ticks hang out there, but you could also put it in the ground, because most of the life cycle of a tick is not on the animal, it's actually in the ground. It can be better than or equal to the chemical pesticide. So you think, wow, this is a no-brainer, let's get on with this. Because it's actually, the tick is a pest of a living animal, then it's not quite as simple, because the registration process, which is now happening in Kenya with MET 7, has to go through the veterinary science equivalent to Pest Control Products Board, which is for fruit and vegetables. And I'm a bit disappointed, at very least, at the speed at which this is taking. It's extremely slow. I don't understand why it has to be so slow, and it needs to speed up, because it can if it wants to, and it should, because globally we have a problem. So here is just a little bit more information about the life cycle for those of you not that familiar with ticks, and predominantly most of its life is on the pasture. And even though Henry and I are retired, we still actually involved with farmers in the UK. You may or may not know that there is a company called Real IPM UK, and that happened because a group of farmers from the UK, leading farmers, came to Kenya on a study tour funded by DFID. This was before we retired. And when we told them this, that, and the other, what we were doing, they were saying, well, how come you can afford to do that? See, afford to do that comes up again. It's more about the economics than the biology. And so as a result of that, Real IPM UK was formed. They are putting through registration in Europe metarhizium 69, Metarhizium 78 and Metarhizium 62, not, unfortunately, Metarhizium 7. However, I have it on good authority from South Africa that Metarhizium 78 is almost as good as Metarhizium 7 when it comes to control of ticks, particularly in the pasture. So, you know, we have to think outside the normal box. So, yeah, there might be more innovation, Wes Graham, about, you know, how you apply this predominantly to pastures. And perhaps there might be opportunities for attractants to redistribute the ticks in the pasture. Basic blanket application may or may not be realistic depending on application methodology, but generally the tick experts are here. They're not evenly distributed in a pasture or paddock where you've got animals, say, tend to congregate in areas where you've got longer grass or where the animals come to drink. So yeah, registration has been disappointingly slow. And here we have fruit fly.
Okay, so this is our last case study, and it's primarily just to give you the problem, which is it's a highly mobile, very difficult to target pest. Expensive options include male sterile release, aerial spraying of spinosad, mass trapping, but we showed in the laboratory that biopesticides, the metarhiziums, can kill fruit fly, but the challenge is how to target these flies flying around a huge mango orchard or whatever. And there were opportunities for lures and auto-dissemination methods. And I want to show you a video. If we have the technology. Here we go.
I'm a mango farmer and I want to show you how Rio IPM is making a big difference in my mango farming business in Kenya. Right now I have 383 mango trees. This is my enemy, the larvae of the fruit flies. For every 10, we would lose 5 mangoes, and this is a big loss. And then they are not going to the market, and they just remain in the farm as a waste. The problem we face with the chemical control is that when you offer a cover spray, you would kill the fruit flies and also some of beneficial insects in the orchard.
ICIPE, or International Center for Insect Physiology and Ecology, discovered a revolutionary insect-killing fungus called Metarhizium 69. As Real IPM, we picked up on that discovery and developed into this remarkable control for fruit flies. So the device comes with 2 components. There is a Metarhizium powder, and then we have a pheromone plug. So essentially, we would like the fruit flies themselves to disseminate the killing agent to get the powder out to the other flies as well. The male fruit flies, in this case, will fly in here as they're buzzing around to follow where the female pheromone is coming from. And in that process, they pick up the spores. And after a while, they go outside to disseminate the spores to other fruit flies. Then we have a bottom can here that will put a food bait, or in this case what is commonly available here in Kenya, we can put molasses in there. It will attract a broader range of species, both male and female, which is what most farmers have been lacking.
hung 16 of these traps in my orchard of 4 acres. Oh, look, one of them is attracting a fruit fly. I like to see that.
Compared with other existing fruit fly control mechanisms, this is a groundbreaking solution that we believe we can offer to farmers both here in Kenya and worldwide as well.
The market in Europe of dried tropical fruits is growing enormously. It's growing at a rate of about 13% a year. But one of the big challenges in the Kenya market and worldwide is dealing with issues such as fruit fly. The global market is telling us that you must not have residue levels. So our job is to really work with the likes of Real IPM to help use biopesticides and reduce those chemicals that are used in fruit. With a new device, with a new technology, it's so exciting.
What Real IPM and Meru Greens does is that we go about protection of our fruits and vegetables in a biological way. The large-scale farmers served with packages that are suitable for them, and smallholder farmers being served with packages that are affordable, that is just enough for that particular season. And sometimes for that particular application, integrated pest management is the way to go, is the future for the world.
Fruit fly is a very huge menace worldwide, and we have got the solution which is cost-effective, environmentally friendly, very, very effective and sustainable in the long run.
We are happy to see Real IPM spreading its wings and covering the whole world. We are advising the farmers to switch over to the new technologies whereby we use biological control methods instead of chemicals. That's my advice.
Sorry for the advert and the introduction. Just to wind up then, biocontrol in Kenya. Biocontrol is now mainstream crop protection technology, certainly in East Africa. It's primarily a private sector development. There are at least 8 biocontrol companies producing biocontrol agents within Kenya, which has all happened in the last 22 years. There's significant reduction in pesticide use across a range of crops, and this has implications for operators, consumer safety, the environment. There are over 30 biocontrol organisms registered for use in Kenya. So that's many more than there are in the UK. So that's a pretty good achievement. And biopesticides, I think, are probably more appropriate for use by the small scale grower because they're not live insects. They're spores in a jar that have persistency, last longer, and as opposed to if you're dealing with a live predatory mite, it's got to be on the crop within 48 hours. It's got to be kept cool. There's a cool chain involved. So if we're looking at users, the biopesticides probably have a bigger role to play with small scale grower. And the biocontrol industry can't be laggards and rest on their laurels because invasive pests seem to come up every week with a new invasive pest. False codling moth is the current challenge in many of the crops in Kenya. So that's biocontrol. A little bit about Real IPM. We established in 2003. I would like to think we're not a snail, or we weren't a snake oil business at the beginning, or still aren't. The company now employs over 300 full-time employees. Okay, so there are 300 to 400 million predatory mites produced every week. They're exported globally now. Even in our day, they were often going into Japan or else. They'd be produced and put under someone else's label, but they would still be going out of Kenya. I have to give you on the Radio 4, you know, the Truth Not Truth, that program. What's it called? Something like that. They said which was the most live animals going through Heathrow, and it was predatory mites. There are millions of them, and they said, well, is it millions of crocodiles or whatever it is? And the most traded or going through Heathrow is predatory mites. There are millions of them. Okay. The biopesticides produced by Real IPM are going through EU registration. Don't hold your breath. And Real IPM, we left Real IPM 5-6 years ago, and it's now owned by a company in Belgium, which are carrying on the good work. If you want to find out more about Real IPM, Google Real IPM in Kenya, you can find out all about them. Okay, can I just talk about private sector a bit more? And I think private sector in Africa is maligned a bit because of its supposed exploitation. But we had a medical centre, full-time nurse, kitchen garden, lunch was provided, we had staff bus, we have a bicycle finance scheme, school fees are paid, staff saving and loan scheme operated, staff and customer training, basis and facts, which is a UK qualification. So, and when Biobest took over, they couldn't believe that the turnover of staff was 5% or less. They said, to get new ideas, you should have at least 10% turnover of staff to create ideas to bring into a company. Of course, we didn't agree, and we don't like exporting our knowledge to a competitor. But anyway, that's an interesting conundrum. And then Real Life today operates Kaizen as a business philosophy. There's lots of solar energy generation. 75% of all the greenhouse surfaces, of which there are 12 hectares, now collect water. And customer packaging that we send our products out to are recycled at least 5 times before they have to be thrown away. So I think this all adds up to sustainability. And my final slide is that biocontrol, I think, has made a significant goal to the development goals for users, livelihoods, health, environment. If you just take Real IPM or the other 8 companies, but also our customers, the growers, their employees, and the situation around Lake Naivasha where they might grow their crops or elsewhere. I think Kenya's led Africa in the biocontrol technology, and that's mainly due to Kenya is particularly private sector friendly. It might not be the case in other African countries. And I genuinely think the private sector has created wealth for the general population. And I think donor recognition has now come about in the 20 years that we went to Kenya, and now the private sector, the donors have recognised that the private sector has a role to play in some form or other. Thank you.
My goodness, to follow that, tremendous positive change of moving since it was combined in 1960.